Hello everyone, welcome back. It has been a while, but here I am making another Minecraft video, and it's been 2 years, but I wanted to show you guys an old project I made. So what we have here is an 8-bit Redstone computer. It's not the best. I am currently working on another better one. And so, but let's start off by showing you the different components. Right here, this is the 8 bytes of memory that the computer has. It's 8 general purpose registers that feeds into the arithmetic and logic unit over here, which is controlled by the ROM, where the program memory is. And so each line will select 2 registers as an input to the ALU, and select an output register, so what the output will be saved to. And then there are more lines over here to say what operation in the arithmetic and logic unit I want to do. And then a few more lines to handle jumping. So sometimes in your code you get to a certain point in which, depending on different circumstances, you'll want to do one thing or another thing, and so the jump allows you to do that. Over here, this is a part of the program memory. This is the binary decoder. It converts the 8-bit program counter here and selects which line of code to execute currently. And so here, as I said, this is the program counter. Every clock cycle, the program counter will increment by 1, which will select the next line of code. And so back here we have this is part of the jump logic. Basically, once we decide we want to jump, it puts the line of code that it wants to jump to onto these lines, and that gets inputted into the program counter. Over here behind the ALU, this big spaghetti noodle of redstone wires is the jump logic. It's what actually decides, depending on the criteria we set and the conditions on the output of the ALU, if we should jump or not. So there's a bunch of different logic gates, AND gates and OR gates and exclusive OR gates, to decide ultimately if we should jump or continue on to the next line of code. So let's see it in action. Right now I have a program loaded into it to compute the Fibonacci sequence, and so let's see that running. Right here is the redstone clock. If we turn it on, what determines how frequently we should run an instruction. And so set it to run too fast, and the circuitry won't be able to keep up. But right now it has begun running. So we have a 1 on the output line here, and it will move the different values it has around between some of the different registers and then add them together. So now we have a 2. So that stored it into an output register. Now it's moving the 1 over to the first address in memory, the 2 into the second address of memory, and then we'll get the sum of the 2, which is a 3, 1, 1 in binary, and that saves it into the third, and then it will move those two values back up to the front. So move the 2 over to the first address, the 3 over to the second address, and right here you'll see the jump line activate right there. So we jump back to add them together, and we get 5. It stores it, and then we'll move over the next 2. Then we'll jump back to the beginning of the loop and add them together, which is 8. 5 plus 3 is 8. So I'll just let this run here for a moment. So yeah. Alright, so here now reaching the maximum capacity of the computer. It only has 8 bits, so it can only store numbers up to 8 binary digits long. And so now the computer will overflow, and it'll just start going into random numbers. But I'll go ahead and stop it, and once it finishes this last instruction, it will it will now be finished. And so yeah, this is obviously it's very limited in memory, but this was a fun project from a few years ago, and I enjoyed putting it together and learning from it, and I'm excited to show you the upgraded version once it's finished. So thank you for watching, and hope to see you later.